Good afternoon, ladies and gentlemen. I'm Al Hassan Nour, computer science student, and it would be great to connect with you on Twitter or LinkedIn. So in this talk, I'll be talking about your first steps toward data science. Today, I'd like to provide you with all the information you need to quickly get up to speed on this exciting new topic. I'd like to start with this beautiful quote that says, "Data is the new oil for all the industries, and data science is the electricity that powers the industry." The purpose of this executive briefing is to answer the following questions. What is data science? Why is it important for you and your business? And how do I get started becoming a data-driven organization with data science? However, in order to keep things interesting, rather than starting with data science, we're going to start with why data science is important for you. My hope is that this will show you the value of data science before we go into the details of what is it and how it works. So let's get started. To answer this question, I'd like to show you 3 examples of how data science solves common problems that exist in your business. First, let's learn how we can use data science to make better decisions for our business. Imagine that you're sitting in a product development meeting. You're trying to decide if your company should create a new product or not. Some of your team members are arguing that the product will be a huge success, while others are arguing that it's completely unnecessary and will likely be a total failure. How do you, as a decision maker, decide whether to invest thousands or potentially millions of dollars developing this new product or not? In traditional decision making, to make this kind of decision, we typically rely on guesswork, human biases, and in many cases, the flip of a coin. We all know that these are less than ideal ways to make critical business decisions. However, many of us are unaware that there is a better way to make these key decisions. So data science solves these problems in an entirely different way. Rather than using guessworks or coin flips, we use the scientific method and data to provide evidence for or against our hypothesis. The scientific method is a process of answering questions that involves a few steps. We ask a question, form a hypothesis, design experiment, collect data, analyze the data, draw a conclusion, and take action. This method is evidence-based, objectively measurable, reproducible, and transparent to everyone involved. In fact, initial findings from MIT research show that companies that are implementing data-driven decision-making practices had 4% higher productivity and 6% higher profit than traditional businesses. Some examples of how we can use data science to make better decisions include using customer and segmentation to create highly personalized marketing campaigns, predicting customer churn, and intervening to keep customers loyal to our brand, running A/B tests on our website to maximize click-through rates and customer conversions, performing sentiment analysis to determine how our customers respond to our products on an emotional level, and providing portfolio managers with recommendations on investment in asset diversification. The key difference here is that we are using data and the scientific method in order to help us make critical business decisions instead of traditional flawed decision-making practices. This is just one of the many ways that data science can help our business. Next, let's learn how we can use data science to create smarter products. Imagine you just bought a brand new coffee maker, then you try to plug it into the power outlet. However, you quickly discover that it has no power cable. In fact, it doesn't even run on electricity. Instead, you have to heat the water on the stove to brew the coffee. In addition, without temperature sensors to regulate the heat of the warming plate, the coffee always turns out tasting burnt. Without electricity, you're stuck grinding that coffee by hand. You think to yourself, why does this have to be so difficult? Why couldn't they have just used electricity to make this product more convenient for me? Well, in the very near future, your customers are going to be equally frustrated if you aren't building data-driven artificial intelligence into your products to make them more convenient to use. With data science, our products can become intelligent. We can use machine learning to create products that solve complex problems for our users automatically. We can use anticipatory design to anticipate the needs of our users and minimize the number of choices they need to make. In addition, we can use product telemetry data to better understand our customers, their preferences and behaviors, and how they actually use our products so we can improve their design and operation. We can embed this intelligence directly into our products to provide real value to our customers. Some examples of product made smarter with data science include Google Home turning on the lights in your house based on a voice command, Apple's iPhone recognizing your face and automatically unlocking your smartphone, Netflix learning your movie watching habits and creating playlists of movies that you're likely to enjoy, and Microsoft Applications Insights providing you with statistics about your customers' interactions with your products in real time. Finally, smarter products allow us to learn more about our customers and their behaviors by providing us with data on their interactions with our products. This allows us to improve the design and operation of our existing products and create new products that will provide even more value to our customers. Now let's learn how we can automate manual processes with data science. Imagine you're an employee reviewing credit applications. Each day you clock in at 8 a.m., review the same credit applications forms all day long, and clock out at 5 p.m. It's definitely not the work you were hoping to do with your education and certainly not what you want to be doing for the rest of your life. Unfortunately, this work needs to be done, and currently it requires a human to perform it. The first problem here is that for employees, repetitive mental tasks are boring, uninspiring, and highly prone to errors. The second problem here is that for most businesses, labor is the biggest expense. So we want our employees to be working on tasks that will provide the most value for our company. However, data science has led to the emergence of a new era of automation based on a data-driven AI. Data science is automating knowledge work with a new set of tools. With machine learning, deep learning, reinforcement learning, and artificial intelligence, we are now able to automate a variety of tasks that were previously only able to be completed by humans. This frees humans to work on tasks that they actually want to be working on. In addition, it allows our business to significantly lower our cost of human labor. Machines can run 24 hours per day and 7 days a week without needing breaks, vacation, or employee benefits. Finally, it can reduce the number of defects in our work caused by human error, lack of precision, and miscommunication. Some examples of automation made possible by data science include automatically approving credit applications based on customers' demographic data and financial history, automatically detecting fraudulent credit card transactions before the transaction has completed, automating tech support with chatbots that can answer frequently asked questions, automating quality control with machines that can inspect products for visible defects, and automating simple programming tasks by applying deep learning to program synthesis. With data science, we now have the ability to automate tasks that were previously only done by humans. This can be good for our business as well as for our employees. However, there will likely be significant social and economic side effects caused by this level of automation that we as a society will need to address over the next few decades. So now that we know why data science is important, we need to answer the next question: what is data science? Data science is an interdisciplinary field composed of computer science, math and statistics, and domain knowledge that seeks to derive insight from data. Data science is the intersection of these three respective disciplines. Another way to think about it is that data science is the intersection of data engineering and the scientific method. The goal of data science is to transform data into knowledge that can be used to make rational decisions so that we can take actions that help us achieve our goals. So what is a data scientist? A data scientist is someone who performs data science as a profession. However, a data scientist is more than just a scientist, more than just a data analyst, and more than just a software developer. Sorry. They possess all three sets of these skills. Sorry. Other roles you may find on a data science team include a data engineer, someone who has a deep understanding of the data, the database, and the infrastructure who can find, transform, and clean data. And the subject matter expert is someone who has a deep understanding of the business, who can provide guidance in context from a business perspective for the data. Also, he can give the analysis results. You may also find other roles, including a project manager to oversee the project and remove impediments for the team. Software developers to implement production code for data science products, or designers to create user interfaces and user experiences for data science products. The next question we need to address is what set of skills are necessary for data science? In general, the skills commonly associated with data science are programming computers using programming languages like SQL, Python, and R, working with data that is collecting, cleaning, and transforming data, creating and interpreting descriptive statistics, that is numerically analyzing data, creating and interpreting data visualizations, that is visually analyzing data, creating statistical models and using them for statistical inference, hypothesis testing, and prediction, and handling big data sets that are of volume, automating decision-making processes using machine learning algorithms, and deploying data science solutions into production or communicating results to a wider audience. So what tools are used to perform data science? We'll take a look at the most popular programming languages, relational databases, big data platforms. For programming languages, the most popular language is SQL. SQL is a very important language in data science because of how much time data scientists spend exploring, transforming, and cleaning data. Next, we have Python, followed by R. R and Python are the two workhorses of the data science world. So I recommend that data scientists learn both. For relational databases, we have MySQL, followed by Microsoft SQL Server, and then PostgreSQL. MySQL has become very popular for data science because it's free, open source database that is easy to use, easy to maintain, and runs on a variety of operating systems. For big data platform, we have Spark, Hive, MongoDB, and Amazon Redshift. Spark has become the big data platform of choice for data scientists in recent years because of its speed, scalability, ease of use, and open source license. Finally, we need to address the question, how is data science performed? The general data science process works like this. First, we find a question that we want to answer. This can be a hypothesis we want to test, a decision we want to make, or something we want to attempt to predict. Second, we collect the data for our analysis. Sometimes this means designing an experiment to create new data. Other times, the data already exists. Third, we prepare the data for analysis. We need to clean and transform these data to get them into a form suitable for analysis. Unfortunately, this step often accounts of roughly 80% of the work in data science. Fourth, we create a model from our data. We use this model to provide evidence for or against our hypothesis to help us make a decision or to predict an outcome. Fifth, we evaluate the model. We need to determine if the model answers our questions, help us make a decision, or creates an accurate prediction. Finally, if everything looks good, we deploy our model into production. This could mean communicating the results of our analysis to others, making a decision and acting upon our decision, or deploying an application into a production environment. So now you might be wondering, how do I get started with data science? How do I begin leveraging data science on my team and within my organization? First, what are the ingredients of a data-driven organization? In general, there are 5 key ingredients to data-driven enterprises. First, we need a strategy for becoming a data-driven organization. Our data science strategy defines key aspects of how we do business, like what people we need on our data science team, what data to collect and how it's collected, what technology will be required to achieve our goals. Second, we need the right people to help us execute this strategy. We want people that value evidence-based reasoning, that think like scientists and can use data to drive business outcomes. The third ingredient is the data. So we need the right data in order to derive actionable insights. In addition, we need our data to be accurate, reliable, and available. Fourth, we need the right technology. Technology is necessary to build our data science pipeline, to analyze our data, and to automate decision-making processes. Choosing the right technology can make a big difference in the long-term cost benefits and overall return on investment of our data science strategy. Finally, we need to create a data-driven culture. We need to change the mindset of our organization to one that values experimentation and data-driven decision-making. And this is probably the most important of the 5 ingredients. However, it's also the most difficult because it can't be bought or acquired or hired. It has to evolve over time. So what is the process for becoming a data-driven organization? Unfortunately, we can't just throw all of these ingredients together and expect a data-driven enterprise to emerge fully baked. Data-driven organizations are grown and evolved over time. The most basic need of a data-driven organization is the need to collect data. This starts with basic data collection activities, for example, recording transactions, logging errors, etc. Next, we have a need to organize our data. This starts with basic data organization tasks, for example, transforming, cleaning, and storing data. Then, as the company matures, this may often lead to building more robust solutions. Third, we have a need to analyze our data. We need to use our data to explain what's happening in our organization and why it's happening. Then, as the company matures, this can lead to more powerful forms of data analysis. Fourth, we have a need to make predictions. We want to know what will likely happen in the future and how we should respond to these potential scenarios when they occur. This generally involves more advanced types of data analysis, for example, predictive analytics and machine learning. Finally, we have a need to automate. This is where we close the data science loop and remove the human from the process. This involves advanced technologies like artificial intelligence, deep learning, and reinforcement learning. Today, we answered 3 important questions about data science. We learned what data science is, why it's important for you and your business, and how you can get started becoming a data-driven organization. I believe that we're just at the beginning, we are just beginning to see the true potential of data science. Data science is going to have a fundamental and profound impact on software and the IT industry for many years to come. So to end, I'd like to propose 3 new questions for you. Are you prepared for this? Is your team prepared? And is your organization prepared? So thank you guys, and I hope you enjoyed this talk.